morning, students. Today we want to discuss about another method of preparing ethene gas. We say that these alkenes are prepared by dehydrating respective uh, their respective compound, like for example ethene, their respective alkanols, like for example ethene, the dehydration of ethanol, propene, dehydration of propanol. So yesterday we discussed about dehydration process with condensed sulfuric acid, and we discussed about some questions that are possible. Maybe just to make a recap of what we discussed yesterday, we said that ethene gas is prepared by the hydration of ethanol. And the question that you might be asked there is to write the equation when ethanol reacts with it, it's dehydrated by use of condensed sulfuric acid. So when you write the equation, it is ethanol C2, ethanol C2 H5OH. Then you pass Kong sulfuric acid H2SO4 at a temperature of 160 degrees to 180 degrees Celsius. Then you get what? You get ethene, that is CH2, C2, H6, then plus water. Then you balance the equation. That is the first question that you'll be asked in that question. There was a diagram I drew yesterday. The first question will be asked to write the equation. So, and also another question that you must be asked there is the temperatures that are required for the dehydration of ethanol for it to produce ethene. It is a temperature of 160 and 180 degrees Celsius. We also said we can bubble this ethene through bromine, bromine water, or acidified potassium manganate 7. Those ones are oxidizing agents. They normally oxidize ethene. And also potassium dichromate 6. Those ones are oxidizing agents. Also, the purpose of the porcelain is to prevent bumping, which will lead to cracking of the flask. So those are some of the possible questions that will be asked there in our previous lesson. Now today we want to discuss another way of preparing ethene. That is now the hydration of ethanol by the use of aluminium oxide. You dehydrate this ethanol by the use of aluminium oxide. Also, the question that you might be asked here is to write the equation when aluminium oxide dehydrates what? Ethanol. You also get ethene plus water, and the temperature is the same. This heat, the temperature is 160 to 180 degrees Celsius. The purpose of soaking aluminium foil, the purpose of soaking this cotton wool soaked in ethanol is to prevent that this ethanol from what? Is to prevent this ethanol from being from moving within this flask before you start heating this one, or before the temperature rises in this flask. And that's why you need to soak that ethanol in a cotton wool. So the equation there also is ethanol C2 H5OH. Then you pass it through aluminium oxide. Then so this one you get, it is ethene C2 H6, then plus water. So that is now the equation. Then you come and collect your ethene gas as simple as that. So that's now what is now there. So the aluminium oxide is both a catalyst and a well dehydrating agent. So the two functions here is of aluminium oxide is dehydration, and also it also acts as a catalyst. Then there was sodium hydroxide in the another diagram. That sodium hydroxide normally removes two gases, that is sulfur oxide and carbon 4 oxide. So those are the two methods of preparing alkenes. If it is propene, you prepare the same way using propanol. So let's move to properties of alkenes, and we want to start with the physical properties of alkenes. Physical properties of alkenes. Physical properties of alkenes. So the physical properties of alkenes, like other or like alkenes, they are colorless, odorless gases. Alkenes that start from number two, ethene, propene, butene, they are gases. Then from pentene up to the ethene, those ones are liquid. But from number 11, as we go onward, those ones are solid. So those are the physical properties. So number 1, they are colorless, odorless. Then it is lightly soluble in water, and that's why they are collected over water. So the first one is colorless and odorless. Let me just say colorless. Then so you just name the name of the alkene. Like for example, we can say ethene is colorless. Ethene is colorless because there are some alkenes that are not colorless. Like for example, liquid like pentene, heptene, they are not colorless. Then you can also talk of slightly soluble in water, and that's why they are collected over water method. Slightly soluble in water. Slightly soluble in water. Also, the solubility of alkenes decreases with an increase in the molecular mass. So when the molecular mass of these alkenes increases, the solubility decreases. Why? Because as the structure increases, it normally increases the number of covalent bond, or the number of bond between the atom, and also the molecular formula also increases, and therefore the energy used for breaking these alkenes also increases, and therefore the solubility increases as the chain gets longer, or the molecular formula gets longer. Then it is soluble in organic solvents such as methyl benzene. It is soluble in methyl benzene and tetrachloromethane. Then the melting and boiling points of alkenes increase in the number of carbon atoms with the increase in the molecular forces. Also, boiling point and melting point of these alkenes also increases with an increase in the molecular formula because of an increase in the molecular forces, or the bond between those two atoms or carbons. So that is now physical properties. Now there's not much there to say, talk about it. So let's move to chemical properties of alkenes. So alkenes are more reactive than alkanes due to the presence of the double bond. So that double bond is the one that makes alkenes to be more reactive than alkanes. You might get a question: give a reason why methane is not considered as an alkene. It's because a double bond needs another atom to be stable. When a double bond is attached to a carbon, it needs another atom of carbon for it to be stable, and therefore it is more reactive than alkanes. So we now start with the reactions, chemical properties. Chemical properties of these alkenes. So the first chemical property is combustion. And combustion is everywhere. Combustion. This is whereby it normally reacts with the oxygen. Like for example, when ethene C2H6 reacts with the oxygen, normally produce carbon dioxide and water. Then you ensure that the equation is balanced. So you put here 2, then you come and put here. So when you put here 2, then you put here 3. So this one is 3, and this one is 6. This one is 4. 2 times 2, that is 4. So you put here what? You put here 2 times that is 4 plus 1 plus 3, that is 7. So when you come and place here, when you come and place there, this one is not 6. Sorry for that inconvenience. This one is 3. This one is 3. This one is 4. Also here is 4. So when I put here 3, and I put there 3, then I put here 2, the equation will be balanced. The equation will be balanced. So this is a gas, this is also a gas, this is a gas, and this one is liquid. So that is it. So that is what we call combustion. Combustion, that's the first physical property. So when they burn in limited supply of oxygen, it normally produces carbon dioxide. But when it burns with excess supply of oxygen, it normally produces carbon oxide. We also have what we call addition reaction. Addition reaction. Some alkenes undergo reaction because of the double bond. An addition reaction is one in which one molecule adds to another to form a single product. Addition reaction. Just addition. Just add one atom to another to form, like for example, hydrogen. Like for this case, like for example, we have ethene. Let me just use the molecular formula, the structural formula. The structural formula. So when you add, so this is ethene. So when you add hydrogen plus hydrogen, it forms what? So you just add. So this double bond will now become single. These two molecules of hydrogen, you know, a bond is a bond must be having 2 atoms in each side, or a bond is made up of 2 atoms. A bond is made up of 2 atoms. So when you remove one bond here, it will be attached with this one hydrogen. It will be attached with one hydrogen. So you just add here these 2 hydrogens here. So it will be now addition reaction. That is what we call addition reaction. So this is addition reaction. Just add hydrogen, 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 hydrogen. So that's what we call addition reaction. It now form one compound and it forms a single bond. So this hydrogen comes and they get attached to one bond from the double bond there. So that's what we call addition reaction. That's addition, adding a hydrogen molecule or an atom to form a single bond. That's what we call addition reaction. We also have another reaction. We call it halogenation. 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 So halogenation is also addition of halogens on an alkene, like addition of bromine atom. Like for example, I have an ethene here. It has hydrogen, 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 and hydrogen at that particular point. Then I add bromine molecule, so it forms what we call halogenation. So that bromine will replace what? A double bond. One bromine will be attached to the first carbon, and another bromine will be attached to the second carbon. So that's what we call halogenation. You can also use another halogen of chlorine. I can use chlorine, ethene, then plus 2 atoms of chlorine, that is now chlorine molecule. It forms another chlorine. We have here chlorine here, then hydrogen, chlorine on the second carbon, then hydrogen. So that is it. So that's what we call halogenation. That is the second type reaction of the of what? Of hydrohalogenation. Then we also have another one. When bromine is dissolved in water and reacted with ethene, the following reaction takes place. So when you take bromine or chlorine or iodine, then you dissolve in water, it normally forms hydrobromine. Like for example, this one, when you add bromine in water, it forms hydrobromine, or it forms bromine water. When you add iodine, it forms iodine water or hydroiodine. So like for example, when I react bromine molecule here, bromine molecule plus water at that particular point, it forms what? HOBr. Forms bromine, hydrobromine. Forms hydrobromine. It forms hydrobromine. So that is it. So when you take this hydrobromine at this particular point, like for example ethene, then you react that one with that hydrobromine, HOBr. So it's going to form the product called 2-bromoethanol. 2-bromoethanol. And take note of this equation. So this OH will be attached to the first carbon. OH will be attached to the first carbon, and then bromine to the second carbon. So this is now OH attached to the first carbon, then bromine to the second what? The second carbon. Then of course we have hydrogen on the other side. Then we also have what we call hydrohalogenation. Hydrohalogenation. This one is simple. Just taking hydrogen, then you add an halogen. Like for example, this one is ethene. It is reacting with the hydrogen bromide. So when you continue with the chemistry, there is a law that you learn called Markovnikov's rule. But in your level, we will not learn that one. We just know how the hydrogen will become attached to the first carbon, then bromine the second carbon. But when you continue with chemistry to advanced level, you learn what you call Markovnikov's rule. What rule that will lead you to know if bromine will attach the first carbon or hydrogen attached to the second carbon. So that's what we call Markovnikov's rule. But at your level, you just know hydrogen go to the first carbon or it can go to the second carbon, whichever way. So this particular point, bromine goes to the second carbon, hydrogen goes to the first carbon. Hydrogen goes to the first carbon. You can also use hydrogen chloride, you can also use hydrogen iodine, you can also use any hydrogen combined with any halogen. Let me use another one of chlorine. Hydrogen, then plus HCl. We're going to get chlorine, then hydrogen, then hydrogen. So that is it. Then if possible, you give the name of that product. Like for example, this one is what? Bromo. This one is, the first one you see. The name of the product you see, bromoethane. bromoethane or 2-bromoethane. Then the second one is chloroethane. That is it. Then you also have hydrogenation. Hydrogenation is just the same as addition reaction, the one that we did here. But for that addition reaction, we normally have conditions necessary for addition reaction or for hydrogenation. Conditions necessary. Number one, we need to have a nickel catalyst. That's now where question will come. They will draw for you. They will write for you an equation. Then they say you give the condition. The condition number one for hydrogenation or addition reaction is a temperature of 150 to 250 degrees Celsius. Then the catalyst is nickel catalyst. We did there. Addition reaction, it is here. The condition here is nickel catalyst, and a temperature of 150 degrees Celsius to 250 degrees Celsius. Temperature of 150 degrees Celsius to 250 degrees Celsius. That is now the temperature. Then the catalyst is nickel catalyst. That is the condition that are required for hydrogenation or addition reaction to take place. Then you also have self-addition reaction. So self-addition reaction, that is now where we have what we call polymerization. Polymerization. Addition reaction, self-addition reaction. So self-addition reaction is where, like for example, when ethene reacts with ethene to form a polyethene or a polymer. Like for example, when ethene, this is now the structure for ethene reacting with the same product. I'm reacting ethene with ethene. Ethene reacting with ethene. Ethene reacting with ethene. It normally forms what we call what? A polymer known as polyethene. So that is how we normally write the polymer. This is how we normally write the polymer. So it is now this way. So this double bond will be now single. So it will now be single bond at that particular point there. It will be now single. Then with the hydrogen attached on each side. Then you have N. This N then is what? N represent what? So like for example here, you can add another structure the same way, but this is now how we write the. So it means that let me just write the two of it. Let me just add this another one here, and also add another one here. Then you enclose. Then you put there what? Then here it is N. So N normally shows the number of carbon atoms. So we normally identify only one structure for you to identify the name of the monomer. They can draw for you a very long structure, but you normally identify the long one structure. Like for example, we identify this one. So then you just know the name of the monomer is what? Ethene. So when you see here you have a bond here you have a bond here. So it normally means that this bond will come and attach here and also attach at this particular point to form a monomer. Then the monomer is ethene. Then if the polymer, you add poly. So this is what you call polyethene. Polyethene. That is the name of the structure. So that is the process of several monomers combined to form a polymer is what you call polymerization. So when ethene molecules join together with each other, it normally form what you call polyethene. when it is propene, it forms polypropene. When it is pentene, it forms polypentene. So where N represents the number of what? Carbon atoms. And N represents the number of carbon atoms from number 2. From number 2, number of carbon atoms. So they can draw for a very long structure, so it is a point for identify. So like for example, they can draw for this structure in an exam. This structure here. Identify the simplest monomer. The simplest monomer. So the simplest monomer here is just identifying this one. You identify this one. Then you come and identify this one. So this is also ethene. That is now polyethene. Polyethene. That is the simplest monomer for that case. But this, then when you add 1, it will be what? 3, add 4. 1, 2, 3, 4, 5, 6. When you add another one, that is 7. So that is it. So that is now identifying the monomer. Then you add a poly to form that polyethene. Then we also have another reaction known as addition reactions with oxidizing agents. Just addition reaction with the oxidizing agents. Oxidizing agents. So we normally have oxidizing agents. You have potassium manganate what? Potassium manganate 7. Potassium manganate 7 or potassium permanganate, whichever way. Potassium permanganate. That is now the first oxidizing agent using potassium permanganate or potassium manganate 7. So when this ethene reacts with the potassium manganate 7, it normally forms a diol. Oxidation reaction normally takes place to form what we call a diol. A diol. So like for example, when this ethene reacts with undergoes oxidation with potassium manganate 7, it normally forms. It is now oxidized. It is now oxidized to an alkene. So this this oxygen normally have here 4 oxygen. So normally have another oxygen will come and attach here. Another one here, then hydrogen. Also another hydroxide will attach there, then H, then H. And these are common question in exam. Then they'll ask you to give the name of this product. So the name of this product is 1,2 ethane. No, it is ethane 1,2 diol. Ethane 1,2 diol. Diol. Ol means hydroxide. So you can see you have 2 hydroxide there. So it is ethane 1,2 diol. Also, for propene, when it is oxidized, it will form propane 1,2 diol. Hydroxide will attach to the first and the second carbon. The first and second carbon. Also pentene, it will form pentane 1,2 diol. So take note of this equation. They normally ask in an exam. Also, they will also tell you to give the observation for this particular case. What is the color of potassium dichromate? Potassium permanganate. What is the color of potassium permanganate? And what or how does it changes when it reacts with this ethene? So potassium permanganate 7, is it purple?
Yes, purple.
Yeah, it is purple. It is purple in color. So when it reacts with this one, it will change the color to colorless. So that is another observation. They have to give the observation. the purple color of potassium manganate 7 changes from purple to colorless. That's the first observation. Will change to purple to colorless. Also, this is now a chemical test, a physical test, because you can see their own eyes. A physical test for alkene, and it normally comes in practicals. This is a physical test for alkene, and that one shows that it is an alkene. We also have the hydration reaction using corn sulfuric 6 acid, reaction using concentrated sulfuric 6 with the Kong H2SO4. So also I'm using ethene because that one is the simplest. Then it is now Kong H2SO4. So in a form what? Ethyl hydrogen sulfate. It forms ethyl hydrogen sulfate. Ethyl hydrogen sulfate. Ethyl HSO4 forms HSO4. So this one is ethyl hydrogen sulfate, ethyl hydrogen sulfate. So then here it forms sulfuric acid to form ethyl hydrogen sulfate. So that is it. One hydrogen, the double bond will now will be broken here to form a single bond. Then the bond, one hydrogen becomes a tight, and that another hydrogen sulfate becomes a tight to another. That's another bond, that's another side. So it forms ethyl hydrogen sulfate. So when ethyl hydrogen sulfate is added to water and warmed, the product formed is now ethanol. So when you add this one in water, or when you take this one then you react with water, you form what you call ethanol. Ethanol will be formed as the product. Ethanol will be formed as the product. So test for alkenes, we normally have what we call additional reactions for alkenes with bromine and acidify potassium permanganate or manganate 7 can be used for the presence of a double bond. So the test for alkenes, number 1 is by use of bromine water. Bromine water is yellow. Is it so?
Yes.
Bromine water is yellow. So when you add bromine water to an alkene, or when you add an alkene to bromine water, it forms brown or whatever. So it is yellow. So compound with water, such as the hydroxyl group of water remains intact. Generally, the hydrogen atom is added to the first ethene molecule to break the double bond. Then hydroxyl group is now added. So also you can use potassium manganate 7, which is purple. Then it changes to colorless. Then that shows that it's present of alkenes. That one will do it in practicals. Now for the uses of alkenes, number 1, in the manufacture of plastics, e.g. Or also ethene is used in the manufacture of nylon papers, e.g. polyethylene. Also manufacture of ethanol, e.g. hydrolysis reaction. When ethyl hydrogen sulfate reacts with water, it forms ethanol. So used in the manufacture of water. Ethanol. Then in the ripening of fruits, ethene is also used in the ripening of fruits. So ethene also can be used to ripen fruits. Then finally, manufacture of detergents, normally used in the manufacture of detergents. So that is all about alkenes. In another lesson, we shall discuss about alkynes. Thank you for watching.